All right, so kids, the thing I want you to get, of course, is if f is increasing, that implies that f prime is going to be positive. That's all. And if f is decreasing, as you see here, then f prime, the slope of the tangent, is going to be negative. And that's all I need you to get from this increasing, decreasing function thing, okay? F increasing implies f prime of x is positive, and f decreasing implies that f prime of x is negative. That's all I need you to get from this first thing, except for one weird thing, and I'm going to tell you that weird thing now, okay? Here it comes. If f prime of x is greater than 0 on the open interval from a to b, then f of x is increasing on the closed interval from a to b. Let me show you what I'm talking about in a moment. Look at this interval from A to B, or maybe I'll choose a different one. How about from C to D? Look at this interval from C to D. Are you okay that f prime is greater than 0 on the open interval from C to D? F prime is greater than 0 on the open interval from C to D. Why don't I use the closed interval from C to D? Isn't f prime greater than 0 on the closed interval from C to D? Why can't I use the closed interval? What's wrong with me saying that f prime is greater than 0 at C?
Oh, because 0 right there.
Yeah, it's 0 at C. F prime is 0 at C, and f prime is 0 at D. So f prime is greater than 0 on the open interval from C to D, not the closed interval, because f prime is 0 at C and D. And yet, we still say that the function is increasing on the closed interval from C to D. We include the endpoints. And let me tell you why. Imagine I had a list of numbers. Imagine the list went like this: 2, 3, 5, 8, 11, 12, 9, 6, 2, 1. Let's say that was my list of numbers. And I asked, for which numbers is that list increasing? For which numbers is that list getting bigger and bigger?
Between 2 and 12?
Yeah, 2 to 12, right? It's increasing from 2 to 12, okay? And then if I asked you, for which numbers is that list decreasing, what would you say?
9.
Yeah, 12 to 1. And you go, wait, how can that one point be both part of a interval where it's increasing and also an interval where it's decreasing? And the answer is, I don't know, it just is. You know, there it is, right? 12 is part of the list of numbers that are increasing, and it's also part of the list of numbers that's decreasing. And so you get the same sort of thing where this function is increasing on the closed interval from C to D, and it's decreasing on the closed interval from D to E, right? It's increasing on the closed interval from C to D and decreasing on the closed interval from D to E. So this one point D gets to be part of the interval where it's increasing and also part of the interval where it's decreasing, in the same way that the number 12 gets to be part of this list of numbers that are increasing and part of the list of numbers that's decreasing. So that's why when you look in the back of the book, they're going to ask you for intervals of increasing and decreasing, and you look in the back of the book, and the intervals are almost always closed intervals, and that's why. You guys okay with that?
Mm-hmm.
Alrighty, then hey, that's increasing and decreasing functions. Now it's time for us to, I'm going to skip that. I'm not going to do the chart thing because I'm going to do it with the first derivative test. So, now please look at your sheet. The sheet of AP Calculus notes for section 4.3, the first derivative test. Please do me a favor and read the words of the first two paragraphs.
Oh, wow.
No, just to yourselves.
I like when you apart.
Okay, so what I want you to get out of this is to realize that, number one, the locations of your relative mins and relative maxes is always going to be at a critical point. It could be a critical point where f prime is equal to 0, or it could be a critical point where f prime is undefined. Once you find the locations of those critical points, it's either going to be a minimum, maximum, or neither. And do you notice from my little drawing that if f prime is positive to the left of a critical point and negative to the right of a critical point, you have a relative max because your function is going from increasing to decreasing. But if f prime goes from negative to positive, I don't know if I said that last time, I hope not, but if your f prime goes from negative to positive, that is your function goes from decreasing to increasing, then you have a relative minimum. And if your function goes from increasing to increasing some more, or decreasing to decreasing some more, then you're not going to have a relative min or a relative max, like what happens at C1 on your chart. If you look at C1 on your chart, f prime goes from positive to positive at C1, so it's not a relative min or a relative max. Do you see that also happens at C5? F prime goes from negative to the left of C5 to being negative to the right of C5, and so it's neither a relative min nor a relative max, it's neither. So let me now show, wait, okay, never mind. So here comes the first derivative test. Go ahead and read where it says the first derivative test, read that stuff, then we're going to do some problems. Okay, look at number 1. If f prime goes from negative to positive at C, then would f of C be a relative minimum or a relative maximum? How many people say relative minimum? Yay for each and every one of you. So you know that number 2, if f prime goes from positive to negative, then f of C is a relative maximum. And that's what we're going to be doing. We're going to be determining which, where the critical points are, and then we're going to be looking at the intervals. And you're going to make a chart just like the one I'm making. Because on the AP exam, they're very particular about how kids show the first derivative test. So I'm going to want you to show it like me. So here comes example 1. Let's do this one together. Find the critical points of that function, determine the function's local and absolute extreme values, identify in which intervals f of x is increasing and decreasing. Okay, so here's what we've got. F of x equals x to the third minus 12x minus 5. Next, I'm going to get the first derivative, because the first thing I've got to do is find the critical points. In fact, I didn't put that on here, but I should. I should just put this, steps. Number 1, find the critical points. And then step 2, set up chart to find intervals of decreasing or increasing. So step 1 is to always find the critical points. So let's go for it. I got 3x squared minus 12. That's my first derivative. My critical points are going to be those values of x that make that function 0 or undefined. There's no value of x that makes this undefined. So I'm just going to find the values of x that make this 0. So that equals 0. So I got 3 times x squared minus 4 equals 0. So I get x equals plus or minus 2. Those are my critical numbers. Now, you will set up a chart like this. The first row of the chart will be the intervals of x. Because my critical points are at plus or minus 2, I need to know whether my function's increasing or decreasing to the left and to the right of -2, and to the left and to the right of +2. And so essentially, I'm dividing the x-axis. Here's my x-axis. Here's -2, here's +2. I've got to decide if my function's increasing or decreasing to the left of -2, increasing or decreasing to the right of -2, and then the same thing for +2. So I'm essentially dividing my function into 3 regions, right? I need to know whether my function's increasing or decreasing on that region, increasing or decreasing on this region, and then increasing or decreasing on that region. And so the intervals are going to be bordered by those critical points. You'll go like this: -∞ to -2, -2 to +2, and then +2 to infinity. Those are the intervals of x I'm going to be looking at. The border points have to be the critical points. Next, I'm going to look at the sign of f prime. On this interval from -∞ to -2, I need to know what the sign of f prime is. And I can choose any point on this interval because my function is either increasing or decreasing on that entire interval. If it was doing both, if it increased for one portion and decreased for another portion, then I'd have another critical point on that interval. I hope you're getting that. The fact that there's no critical points to the left of -2 means my function's either decreasing or increasing from -∞ to -2. If it was doing both to the left of -2, if it was increasing at one point and then decreasing at another point, then I would have another relative max to the left of -2. I would have to have a critical point to the left of -2. But because I have no critical point, that means that I'm either increasing or decreasing, but I can't do both. Or there'd be a critical point there. So how am I going to get the sign of f prime on that interval? Just choose any point on that interval. Which point would you like to choose?
-2.
Yeah, I can't choose -1 because -1 is not on this interval.
-9.
Sure, -9, beautiful. So f prime of -9 equals, I stick -9 in, I get 81 minus 4 is 77 times 3 is 231, which is positive. Do I need to put the 231, or is all that matters that it's positive?
It just matters that it's positive.
Yeah, all that matters is positive. I just need to know whether I'm decreasing or increasing. I don't care what the value actually is. So this is a positive. Sure, it's positive 231, but we don't really care that it's 231. Okay, what number would you like to plug in on this interval from -2 to 2?
0.
I think 0 is a great choice. So f prime of 0 ends up being -12. But do I care that it's -12 rather than -13 or -20 or whatever?
Ooh.
No, I only care that it's negative. So it's negative. And then how about, which would you like to plug in that?
26.
What's that?
20.
20, great. So 400 minus 4 is 396. 396 times 3 is 1188. But I don't care that it's 1188. I only care that it's positive, right? And so positive.
Mr. Shady knows his math.
So now we get to do behavior of f. Alrighty. Because my first derivative is positive for all points on that interval, is my function increasing or decreasing?
Decreasing. Increasing. No,
Increasing.
decreasing.
Decreasing. Yeah. 378, right? I said 388, but it should have been 378. I'm so embarrassed.
It's-
No, 380.
398. Isn't it 98?
Oh, who cares? Was that?
3,000.
I was right? It doesn't matter. Okay, well, anyway, behavior of f. Because I'm positive, I'm increasing on this interval. Because this for f prime is negative, I'm decreasing on this interval. And then because this f prime is positive, I'm increasing on this interval. So now here comes my question to you. At -2, do I have a relative minimum or a relative maximum or neither?
Relative max.
How many people are thinking I have a relative max at x equals -2? Beautiful, because my function is going from increasing to decreasing, which means I have a relative max there. So I have a relative max at x equals -2. In fact, that point would be -2 comma, what is that, -8 plus 24 is 16 minus 5 is 11. Great. How about a +2, relative min or relative max? At +2, what is it, which is it? I'm going from decreasing to increasing, so I'm going to decrease, I'm decreasing, then I hit 2, then I become increasing. Do you see that that's a relative min?
Yes.
At +2? And so that's going to be 2 comma 8 minus 1 negative 16 negative 21. Great. They ask determines local and absolute extreme values. How am I going to determine if these are relative or absolute extreme values? What's probably what I'm going to have to do? What's that?
Second.
No. You know what? Graph it.
Oh.
Either graph it or just ask yourself what happens as x goes to infinity, positive and negative infinity. Like here's the graph. Do you see that I'm increasing from negative infinity to -2? Then I'm decreasing from -2 to +2. Then I'm increasing from +2 to infinity. Tell me, is there an absolute min or max for this function? No. And you can tell by just graphing it, though I didn't have to haul out the graphing calculator. It was enough for me to just look at these intervals, increasing, decreasing, increasing, for me to know, oh, my graph must go like that. And so it's going through the basement here and going through the roof there. Let me show you one more thing. They also ask the intervals in which f of x is increasing. So you tell me, name me one interval where f of x is increasing.
What?
Give me an interval of x where f of x is increasing.
To infinity.
Negative.
You guys think of negative infinity to -2?
Yeah.
Sure. F is increasing on negative infinity. That has to be an open interval because I don't know what negative infinity actually is. In fact, you never actually get there. So it has to be an open interval. There's no particular number called negative infinity. But how about the 2? Should that be a closed interval or an open interval?
Close.
Yeah, closed interval for the reasons that I told you earlier. 2 gets to be part of both intervals. So I'm increasing on negative infinity to 2.
-2. Negative.
I'm sorry, -2, thank you, -2. And is there another interval where f is increasing as well? Which one?
2.
Good, 2 to infinity, and remember to include 2. But don't include infinity, because you never actually get there. And finally, my function is decreasing on the closed interval from -2 to 2. So, what are you going to do? Take the first derivative, find your critical numbers, set up your chart. I really want you, particularly on tonight's homework, to write down the words intervals of x, sign of f prime, behavior of f. Don't just give me a chart with a bunch of pluses and minuses without these words, because on the AP exam, they need those words. If you just give them a chart with intervals and then pluses and minuses, you'll get no credit for knowing the first derivative test. Yes?
Is that saying f is decreasing on the closed intervals or open?
Closed. For these guys, it has to be closed.
Okay.
Yeah. So tonight's homework, do you notice I have you doing only parts A, B, and E? Okay, parts A and B, just one second. I'm giving you a homework assignment that only requires you to do this stuff. So increasing, decreasing, and local extreme values. So all you're gonna be finding on tonight's homework are the intervals where f of x is increasing, intervals where f of x is decreasing, and what the local extreme values are. That's all tonight's homework is, just parts A, B, and E on all of those problems. Okay, look at example number 2. I'd like everyone to please repeat this problem for example number 2 on your sheet. Let me see if you guys can pull that off. And I will walk around and help you, although we've only got 3 minutes left. We're not going to get to example number 3. Maybe I'll show you example 3. Yeah, I'll risk being late. Risk making you guys late.
So I'm not late to my next class.
Oh yeah, you're right.
Can't be late. That's awesome.
Ask you if your teacher gave you permission. I took the first derivative and factored example 3 as well. And then, I know the bell's gonna ring, but let's do this. Hopefully you set up your intervals where the border points, there's your border points, -2 and +3. Hopefully you called these guys the intervals of x. And then the next one is going to be the sign of f prime. When I stick in -1,000,000, I get a negative times a negative, which is a positive. When I stick in 0, I get a negative times a negative, which is a negative. When I stick in a big positive, I get a positive here. And so the behavior of f is increasing, decreasing, and increasing. And so I'm going to have a relative max at x equals -2, and I'm going to have a relative min at x equals, what is that, 3? And I'm going to be increasing on the interval from -infinity to -2, and also on the interval from 3 to infinity. And then I'm going to be decreasing on the interval, the closed interval from -2 to 3. So, hey, this is what tonight's homework is. You're going to get a bunch of problems, and this is what you're doing. So all I can tell you is good luck. Set up those charts. Make sure you label the charts properly. We'll talk more about it tomorrow.